As we are moving to a more sustainable planet, organic waste has become an enormous opportunity to be a potential resource that can be recovered and reused in many ways. Organic matter can be reintroduced into the soil to maintain and improve fertility and carbon storage in the long term. In the last decades, anaerobic digestion has proved to be a practical and sustainable way to recover nutrients from waste, produce bio-fertilizers, and at the same time produce energy as biogas. In the region of Lombardy, in the north of Italy, in the province of Pavia, a full-scale anaerobic digestion facility seeks to give the best management of organic waste. This by a careful selection and handling in its reception in a closed building using a biofilter. The infeed is stabilized biologically by high temperature using heat from the biogas produced during the same process. The excess of ammonia is converted into liquid nitrogen fertilizer using a stripping system. The general processing takes place in a series of 3 digestate reactors under thermophilic conditions to produce the digestate as a soil improver. The system uses an ammonia stripping unit to control the total ammonia nitrogen level in the digestate to avoid anaerobic digestion inhibition due to its accumulation and rather produce ammonium sulfate as a nitrogen fertilizer that can be easily stored. Meanwhile, biogas production is upgraded in a combined heat power unit to produce heat and electric energy used mainly for the facility's operational needs. Digestate and ammonium sulfate are used as an amendment and fertilizer locally in extensive crops such as rice. Besides, field management is performed following minimum tillage and precision agriculture principles by injecting digestate into the soil at a depth of 10 centimeters to diminish nitrogen losses into the environment and alter at minimum the structure of the soil. The system has been under study as a demonstration case in the frame of the no-tillage project. Field trial experiments on rice and wheat crops have been monitored for 3 years by analyzing the use of biofertilizers compared with the traditional use of synthetic fertilizers. In doing so, a complete chemical characterization of the recovered fertilizer has been performed during the monitoring. Greenhouse gases has been measured during the agricultural season and ammonia after spreading the fertilizers. Besides, soil sampling has been distributed during the agricultural season to monitor changes in its profile characteristics such as total nitrogen content, available phosphorus, pH, soil texture, and total organic carbon. All agronomical data related to fertilization and field management has been collected together with yield production. By recovering nutrients from organic waste, this system presents a solution for closing carbon, nitrogen, phosphorus loops. Also by the complementary energy generated, its internal use illustrates a less reliance on fossil energy sources and then a lower environmental impact. This can mean economic and ecological benefits as this study pursues to demonstrate when different techniques are well integrated. If you want to know more information about this study and other nutrient recovery solutions, follow us on social media or visit our website, because in N2C we look for a more sustainable planet.